This lesson goes through the process for naming some simple binary compounds. It's worth noting that the process for naming compounds gets much more complicated than what's presented here. This lesson is really only an introduction and teaches you how to name the simplest of binary compounds. When we're talking about binary compounds, we're looking at compounds that have two elements in them. The general format is that we're going to put a prefix that indicates the number of atoms of the first element and then the name of the first element. Then we're going to put a prefix that tells you the number of atoms of the second element, and we're going to put the name of the second element with an IDE ending on it. This is for covalent compounds that have two elements in them. So here's an example. Carbon dioxide is a covalent compound. The first element is carbon. There's just one carbon, so we don't need a prefix on this first element. So we simply put carbon in the space here. The second element is oxygen, and we have two oxygen atoms in this molecule. So we put the oxygen with the IDE ending, which makes oxide, and we put the prefix di in front of it to mean two. So carbon dioxide contains one carbon atom and two oxygen atoms. This is where the name carbon dioxide comes from. Here's another example, H2O. We know it by its simple name water, but we can give it its formal chemical name using the structure I've shown you. The first element is hydrogen, and we have two of them. So we put the name of the first element, plain old hydrogen, and then a prefix in front of it, di, that means two. So dihydrogen means two hydrogens. That's the H2 in the chemical formula. The second element is oxygen, so we're going to put oxygen with the IDE ending, which will make oxide, and we only have one of them. Now, when we only have one of the second element, there is a prefix that we'll use, and that is the prefix mono. So the formal chemical name for water is dihydrogen monoxide. That means two hydrogens, one oxygen. You'll need to know the prefixes to tell you the number of atoms then. The table here shows you the prefixes you'll need, and you do want to make sure that this is in your notes. If you have one atom of an element, the prefix is mono. 2 is di. 3 is tri. So for 3, you can think of a tricycle. 4 is tetra. If you think of the game Tetris, that's a game where you're playing with pieces that have 4 blocks each. That's where the tetra comes from. Penta, think pentagon, a 5-sided figure. 6 is hexa, a hexagon. 7 is hepta. I don't have any great memory tricks for that one, sorry. 8 is octa, like an octopus. 9 is nana. Thankfully, that one starts with the same letter as 9. And 10 is deca, like a decade. So, for example, we already saw that carbon dioxide has one carbon and two oxygens. The compound P4S10, that is 4 phosphoruses and 10 sulfurs, would go by the name tetraphosphorus decasulfide. Tetraphosphorus is 4 phosphorus, decasulfide is 10 sulfides. Notice that the prefix mono is only applied to the second element. If there's one atom of the first element, we don't put the mono prefix on it. So for example, CO2, 1 carbon, 2 oxygens, is carbon dioxide. We would not call it monocarbon dioxide. However, carbon and oxygen can form another compound, that is carbon monoxide, CO. That's 1 carbon, 1 oxygen. So this goes by the name carbon monoxide. It's not monocarbon monoxide. That mono prefix only gets applied to the second element. Another thing you might ask is, how do I turn an element into that IDE thing? Well, here are some common elements that might be the second element in a covalent compound. And here are what we call the stems of them. So oxygen became oxide. The stem is ox, we had the IDE. Chlorine will become chloride. Carbon will become carbide. Iodine will become iodide, etc. The reason that I'm showing you just these stems here is that later on in chemistry, once you're off in high school, you learn that there are other endings that can be applied to these stems that mean different things. So there are things like chlorates and perchlorates. And those have different meanings about what is in a compound. For now, we're simply using the IDE ending. So here's a little bit of practice. SiO2. Pause for a minute and in your notes, write out the name for that compound. Do the same for H2O2. Write out the name for that compound. And then on the right, I've given you the name. You try and turn it back into the chemical formula that goes with it. So iodine pentafluoride and dibromine silicide. Next, we're going to look at how to name very simple ionic compounds. So in your notes, you want to make this a new section that's called Naming Ionic Compounds. For the very simplest ionic compounds, it's actually even easier than it is naming covalent compounds. Because for the very simplest ionic compounds, we're not going to worry about specifying how many of each atom we have. We're simply going to put the name of the first element and then the name with the IDE ending of the second element. Notice that there's no number parts in this. So examples, FeS. This is an ionic compound. It's a metal and a nonmetal. Fe is iron, that's the metal. S is sulfur, that's the nonmetal. And so to name this, the first element is iron, so we just put iron in that first spot. The second element is sulfur, so we just put sulfide. So this compound would go by the name iron sulfide. For these very simple ionic compounds, we don't need to indicate the number. Notice that there's no mono, di, tri, etc. in this. In 8th grade, this is all you need to know about ionic naming. Later, you'll find out that the process for giving names to ionic compounds will get much, much, much more complicated. So here's some examples. NaCl. This is an ionic compound between sodium and chlorine. So this is sodium chloride. AlBr3. This is an ionic compound between the metal aluminum and the nonmetal bromine. So this is aluminum bromide. Notice it's not aluminum tribromide, it's just aluminum bromide. Next, we have a compound of calcium and phosphorus. That's simply calcium phosphide. Then we have strontium iodide. And last but not least, iron 2 chloride or ferrous chloride. Why is this one more complicated? Well, this is an example where I told you that sometimes for more complicated ionic compounds, the naming conventions get more difficult. This last one is an example of that. In 8th grade, I'm only going to ask you to name compounds that are named using this simple convention, like shown in the first 4 examples. But it's worth you knowing that there's more out there. So here are some examples of what that more out there might look like. NaOH, we have the sodium hydroxide. That OH part has some unique properties to it, and it goes by the hydroxide name. Nitrate, the NO3 section, goes by the name nitrate. Phosphates, and then we have ammonium sulfate. Ammonium is the NH4 portion of that molecule. Ammonium fluoride, calcium carbonate, magnesium acetate. That whole C2H3O2 thing goes by the acetate name. So you can see that the naming gets really much more complicated.